Okay, good morning, good afternoon, good evening, wherever you are. I am Nick Chase from Mirantis, and I would like to welcome you to today's webinar, Securing Your Containers Isn't Enough, How to Encrypt Containerized Data. Let me go ahead and let's introduce today's feature presenters. We have three. Tim, why don't we start with you?
Good morning, everyone. Hope you're doing well and safe. This is Tim Riley. I'm the CEO over at ZetaSet.
Okay, and Maxim?
Good morning. I'm Maxim Yankovsky. I'm the Vice President of Engineering at ZetaSet.
Okay, great. Tim, do you want to give us just one sentence about what ZetaSet does?
Yeah, sure. We do software-defined encryption, and we've now moved into a DevOps offering, one of the first ones being Docker containers. Looking forward to telling you guys more about it.
Okay, but don't worry, guys. This is about technology, not a product pitch. All right, next. And we also have Brian. Brian, introduce yourself.
Hi, I'm Brian Langston. I'm a pre-sales solutions architect. I've been with Mirantis about 5 years and have had roles on the product side of the company, as well as most of my time on the professional services side, leading a team of OpenStack and Kubernetes architects.
All right, excellent. Thank you. All right, so this is our crew for today, everyone. So a little bit of housekeeping before we get started. If you've never been to one of these, my goodness, how have you avoided it? But in the meantime, there is a questions panel on the right-hand side. Feel free to submit questions throughout. We did get one actually even before we even started, so you guys are really on the ball. You do not need to wait till the end. I will answer the most common question right now. Yes, you will get a link to the slides at the end of the webinar, so you don't need to frantically write things down. You do need to pay attention, though. There will be a quiz at the end. Just kidding, no quiz at the end. But let's just kind of look at where we're going. So what we're going to talk about today is we're going to talk about the goal that we're trying to get to with protecting data in your containers. And we'll kind of give you that overview to start with so you know where we're going. Then we'll talk about where containers are today, the basic security issues and where DevOps and DevSecOps fits into all of that. And then we'll get into the actual encrypting containerized data and why that's not as simple as it seems like it should be. I learned a lot in prepping this. And then what does this mean for customers? How does that actually translate into the real world? And then we will get to your questions. All right, so Tim, can you give us like a 3-sentence explanation of what we're looking at here as sort of our goal topology?
Okay, this is Maxim. I'm actually going to take this.
Sorry, go ahead,
no
Max.
Do that. All right. So what we're looking here is a typical, somewhat simplified Docker deployment with 2 Docker hosts, of course, potentially more than 2. What we're looking at, the important takeaway from this slide is that in Docker hosts, containers are running applications potentially from multiple tenants. And that is the fundamental premise that will kind of permeate the entire presentation, is to not just how do you secure a single Docker host running a single container or a multiple instances of the same container, but how do you secure hosts in multi-tenant environments that are heavily, I guess, cloudified.
All right, excellent. All right, so let us move into the discussion. So we're going to talk here. Let's start with containers themselves. So Brian, how prevalent are containers in production today? Tell us about that.
Yes, thanks. The container utilization graphs we're showing here are provided by the CNCF. A few interesting things to take away here include, if you look at the left side of the graphs, dev test and POC environments have been pretty consistent in how containers are used. Production environments, on the other hand, aren't as well established, but are at least trending upward, as you can see on the graphs. The graph on the right shows us that most containers are running in cluster sizes up to 1,000 nodes. Fewer environments have between, say, 1,000 and 5,000 nodes. A fair number of environments have more than 5,000. So the distribution of the sizes of container environments really varies. There's a couple key things to call out about the role of data in containers. And that is that, as you can see from some of the bullets on the bottom, 69% of the respondents to this survey intend to store sensitive data in containers. So that's a positive, encouraging thing for containers themselves. 94% experienced a security incident in the last 12 months. It probably doesn't take too much to identify some of the big names in various industries that have encountered an attack of some kind. Marriott comes to my mind most recently, I think, from last week, or something like that. But regardless, security is a top barrier to further container adoption, and I'm definitely a believer in that part from this CNCF survey. We'll talk a little bit more about this topic a little later, but that's kind of an overview of where we see containers. Well, so there's kind of a part two of my response about container utilization. As I kind of mentally scanned across the customer environments within Mirantis, we see a lot of different use cases, of course, with containers. Generalizing and summarizing some of the use of containers, we're seeing obviously a lot of our customers improving customer experience, using containers to support new business models. We've been very actively engaged with many of our customers who are trying to maintain their current business model while exploring new, more innovative ways to expand their business, offer new products, offer new services, engage differently with not just their customers, but suppliers and other stakeholders. And then, of course, there's a general goal of increasing operational efficiency, and I've put a few here on the slide outlining where some interesting results are coming from some of our customers. We've got a leading bank that's innovating faster by increasing their deployment rate by 40x. Pretty significant change for that customer. An online payment processor is running 15,000 containers across 700 apps, and that's across multiple clouds as well. So a very distributed, complex environment. And then another impressive statistic we've been working with for one of our customers is scaling by 10x and achieving 65,000 transactions per second for another global payment processing technology company. So stuff like this is happening more and more frequently, and it just shows the level of maturity that containers are having, and kind of what some of the more ambitious and far-reaching benefits are for them. So I think what I can get to here is really describing the role of DevOps with containers, and not to get into the weeds too much here, but what we see with DevOps from our customers is kind of how I frame it in terms of the good, the bad, and the ugly. Most of our customers at this point have pretty well-defined pipeline automation. They have they've got a good handle on pipeline automation. It's driving a consistent deliverable. It's predictable, and they're doing this throughout their dev, test, and production environments. That's why we saw, I think, in the first slide, right, those blue slides from the CNCF. That's why we saw a pretty stable and consistent use across those three environments, but it wasn't so much in the production side. The bad, what I'll characterize as the bad, though, is something that's not so easy with customers, and that is, how do you handle operational and security challenges in a containerized environment? I refer to some of these challenges as the unknown unknowns. In other words, things that you didn't anticipate happening before your container deployment. A lot of our customers started off with the same way that they have with other technology projects, and that is, let's set up a lab, let's set up a POC. And then as that POC progresses, you start encountering additional challenges that you didn't foresee at the beginning. So now that we see the trend towards increasing deployments into a production environment, things start to change a little bit. And for example, companies are starting to ask themselves, all right, well, now that I have a production workload that's containerized, how do I quickly identify or troubleshoot a problem with my containers? Now that I have container sprawl, how do you effectively monitor containers when everything's changing all the time? And for companies that really depend on SLAs, how do you design your SLAs? Can you effectively deliver against them, right? Where you might have had clear SLAs on, say, legacy workloads. Do those transfer cleanly to a containerized environments, and how so? And then when it comes to security, a lot of questions emerge, right? How do you protect your data? How do I even begin to think about security? In many cases, I've personally seen internal security teams are somewhat, caught off guard at the very disparate changes in security when they begin addressing containerized workloads, right? They start asking, what controls are relevant to my workloads and my business. If I look at the various security frameworks, how do things change when I look at those frameworks? How do I stay off the front page of the news? So those are some of the unknown unknowns, and what I refer to as the ugly. To me, what I still see as perhaps the most challenging aspect of containers is the cultural changes that are needed to really adopt and internalize new processes or new team structures in ways that removes the batch-oriented structures of the past and replacing those with continuous workflows. This is not so much a problem with companies that are born in the cloud, but it really is a challenge with companies that have a lot of workloads running on bare metal or VMs who are transitioning to containers for the first time. For many of those companies, the cultural challenges are substantial and pose, in my view, a barrier to achieving the benefits that DevOps can bring. So that's kind of the role of DevOps. I mentioned some security issues in my discussion of the unknown unknowns, and as we've observed and helped many of our customers with their progression through their container journey, what we're seeing, are some common security issues, and this is by no means a comprehensive list of issues, but some of the more common ones have to do with the fact that there is no security by default configuration. And anyone that's been working with containers knows what I'm talking about here. Security by default is not turned on out of the box, if you will. Everything with respect to security has to be explicitly defined, and there's a lot of security features that can be used. You just have to know what options those are and where and how to turn them on. So, not doing that obviously leaves well-documented holes open. So that's a common and key issue that a lot of customers that I've worked with have gone through. The next 2 points are really related, and that is the idea that there are various roles that are represented between your operations team and your application. A general strategy for this is to basically deny all up front and use role-based access controls to grant permissions explicitly wherever necessary. The next bullet about trust and trusted content refers to the idea that organizations need to establish some ground rules about what images are acceptable, whether they come from trusted sources, who's making these, and whether they've been properly scanned according to some predetermined security policies. The last bullet is one that adds an extra measure of difficulty in the sense that just as we talked about access control for users, we're talking about access control for network traffic, and defining and implementing this well can be a time-consuming activity, defining policies and being very granular about traffic flows. But if this is left unaddressed, it leaves significant holes open and increases your attack surfaces. So combining the common security issues with DevOps, there's a relationship here in the form of a term that we hear more frequently, and that is the role of DevSecOps once we transition there. So DevSecOps, what is it? My peers over at Zetaset came up with this definition that I really like. It's really concise and it frames it really well. So simply put, DevSecOps is the augmentation of DevOps to allow for the integration of security practices. So working with containers, security can't be an afterthought. It's complex. It has to be very well thought out, designed, tested, etc. It has to be treated and managed as part of the same DevOps practice as everything else. Companies that are doing this well have expanded their DevOps pipelines to include multiple security gates, right? They might be scanning the images before they're used. They might be scanning the resulting workload prior to deployment. There's many different gates that can be inserted into a DevOps or CI/CD pipeline framework. So those gates can be various types of security scans or the processes that enforce security policies, and that's really what DevSecOps is about, is representing the security competency, and there's a lot of touch points when it comes to security, to container security, that the design and implementation of those touch points has to be done within a DevOps framework in order for it to scale efficiently. It's really the only way to be auditable in a highly dynamic environment. And if you're a part of or work with part of your security team in your organization, you know what I'm talking about, right? There comes a time when you're deploying your production workload that you will have to account for how you establish a security baseline and how you do various checks, how you enforce policy and where those are defined. So fortunately, the role of DevOps allows for a very structured method for defining, right, in code, just like your application is defined in code, and that becomes a very auditable source. So that's kind of the role of DevSecOps.
Well, now that I have audio back, yeah. Sorry about that, everyone. I had no audio for some reason. So let me ask you, so what are the challenges of actually protecting your data then?
Yeah, so here's where I'm going to ask Tim and Maxim to join in and help us understand this piece a little bit better.
So, all right. So guys, why is it different to protect containerized data? What are the challenges?
Hey guys, this is Tim. Hopefully you can hear me okay. I know it sounds like
hear you. Yes.
Wonderful, wonderful. Yeah, and I think this slide does a great job. This is from another survey that was just done recently, that you can tell that it's not legacy anymore with where data is. Data is more fluid, it's more dispersed. Containers tapping into the data wherever they may be geographically. It does bring entirely new challenges whereby in protection of data, one of the bigger things you'll see is there's the integrity that a container needs, and there's plenty of different defense mechanisms or detection or auditing that are out there. But even with the integrity of the container, you still may have the breach, you still may have the data that lies within, and therein lies your issue. The best line of defense and the last line at that point is encryption. And as you can see here, there's quite a few different challenges within containers, but look across both. Ensuring the data security is the top one, and then within security, data security is the top one as well. I think it's data security. I think you can tell that as you roll things into more production environments with containers, and like Brian said in that one survey, there is an uptick in that. I think as more comfort becomes and more acceptance and embracement of a DevOps philosophy, you're going to see more containers move into production. And I think there is a little bit of a hesitancy because of data, which is the prized possession of any enterprise. And I think that this kind of is a great lead into the next slide.
Okay. So how do you actually protect the data?
Yeah, I think if you ask any the conventional wisdom and any expert out there, there's obviously going to be a wealth of different ways to detect, but at the top of the list, it is, again, the prize of all prizes for any bad actor is going to be the data. And the best way to deal with protecting the data is encrypting it. Passwords are great, audit and logging are great, and you can see access and data logging, which is number 3. But number 1 is encrypt it. Now, the second thing, which is just as important, which a lot of people forget, and I think you'll see more and more of the separation of these two as the world gets even more educated about security and encryption, is the actual encryption key that turns plain text into ciphertext. Well, it's just like leaving the key under the mat to your house. That really doesn't protect anything. You can just walk up and get in. Well, same thing, because a lot of folks still view, okay, let me encrypt the data, but I'm going to put the encryption key on the same disks, on the same server or node as the encrypted data. So that doesn't do you much good. In that sense, you need to separate the cipher key onto some other place. Maybe it's another node, maybe it's geographically separated. But no matter what, if you truly want to protect your encrypted data, you have to separate the key from it. Okay.
All right. And so what is DevSecOps? How does DevSecOps fit into all this?
Great question. I think for a lot of people, it needs to become more of a shared responsibility. And I completely understand the current DevOps view of we're on a roll, we're the production, the release, and the continuous innovation, continuous development treadmill is doing a great job. But at some point, you will hit that bump in the road whereby there will be potentials for breach and theft. And at some point, the security team will need to step in, and you have one of two options. One, you can have them insert themselves after the fact, or 2, they can plan with you in concert. And obviously, moving to a DevSecOps type of philosophy means, okay, I understand that security needs to be embedded within there. And I believe the developers are starting to understand that more as, again, container adoption continues into production more. And again, if you look, I think overall, the analogy I like to use is the one that's at the top there. Within a castle, I look at it as the core is the data. Around the outside, you got a moat, you've got guard towers, you've got thick walls. Inside, you have keys to doors. But at the end of the day, if someone gets past all that and gets to the gold, you want to have it encrypted. And that is why we call it the last line of defense. So all of those other tools listed below in those bullets represent the guard tower, the walls, the moat. But again, if the treasure's there and nothing else is there to protect it, there's going to be issues, and there's going to be the breach and all the things that come with a breach and theft, and everyone gets their name dragged through the mud. They have the fines, they have the potential customer and operational interruption and loss of revenue. And at the end, a lot of compliance areas, if you're familiar with it, if there is a breach in the theft, you are able to avoid reporting if the data was encrypted. And we've seen that in GDPR, we see that in HIPAA, and we now see that out here in the Bay Area with the California Consumer Privacy Act. And I know that other states will be adopting something like that. So really, if you instill encryption, what are the drawbacks? What are the hurdles that come with that? And I think that right here, I've made a good point, a compelling one, hopefully, that you should encrypt. Well, why aren't people?
Okay, so so why is it complicated? Why is it difficult to encrypt in containers? I mean, we've been encrypting for decades. Why does the fact that it's in a container make it more difficult?
Well, I'm going to let Maxon chime in a second here on this one because I think it really is a good slide. But this goes back to what I call the legacy data center. Instilling encryption in that, whether it might be self-encrypting drives, full disk, file folder, which is extremely impactful to performance. So is database and of course application. So that's that whole philosophy and strategic way of implementing encryption, it doesn't transfer over into this new world order we are in. And these are the type of things that we view as, if you're going to do container encryption, this is how you should attack it. Go ahead, Maxim.
Thank you. Yes, thank you, Tim. So yeah, it's very appealing. It's really very simple and very interesting. Why don't we use a technologies that we've developed 10, 15, 20 years ago, the wonderful and scalable, somewhat scalable encryption technologies that we've developed in the 90s? Why don't we just use it in container environments? Because, isn't containers are essentially abstractions on top of the operating system, which are essential abstractions on top of virtual machines, which are essential abstractions on top of the good old hardware. So why don't we just encrypt the good old hardware and call it a day, right? So kind of makes sense, and it's very tempting because you can use the tools that you bought, years and years ago. The idea is, if you look at containerization as an activity, everybody will tell you when you take an application and you try to create a containerized version of the application, you don't just transfer the bits and run the application inside the container. You have to split it into microservices. You have to go through certain design or redesign, and that's where DevOps and DevSecOps really come in, which is to say, when you're redesigning your application to run in containers to take the most benefit of the infrastructure, you have to do that with security in mind. And what it means for us as for security vendors, as it should for any security vendor for that matter, is that we cannot just take a legacy tool and drop it underneath the infrastructure and call it a day, because we're going to lose unique association between encryption keys and entities which we are encrypting, and we're going to open ourselves for the brand new set of breaches which hackers, I'm sure, will take advantage of. To be more specific, just draw your attention to a prevalent environments now, which are not just containerized environments, but multi-tenant containerized environments. Whether you go on-prem, whether you go to a public cloud, private cloud, hybrid cloud, it does not really matter, because even within a single enterprise, the IT environments are fundamentally multi-tenant. Your engineering team is sharing the IT infrastructure with your finance team. Yes, in the old days, they'd have separate data center servers, they'll have separate credentials, even separate authentication servers, but today we're trying to manage costs and manage performance by parallelizing and taking advantage of the more powerful hardware. So everything is multi-tenant. And it is even more true in containers, because containers run on virtualized hardware or even on physical hardware, but there is no direct association between a container and a server. Container can potentially run anywhere. So that's why we can't just say, why don't we just encrypt the hard drive on the server and call it a day? We really need to get into the storage layer of the container framework and create a correct and cryptographic tie between the container and the container storage. That would allow us to make sure that not only the container data is protected, but also in the event of a compromise, the compromised container does not expose other containers' data to the attacker.
Okay, so let's talk about storage then. How does this all fit in?
Yeah, so there are three very important key points. Is that encryption must follow storage. What it means is that, like I said in the previous slide, containers will share storage, they will share environments, but they should not, under any circumstances, share encryption keys. We've been doing encryption for a very long time. One thing we figured out, encryption is really easy. Encryption in production is really, really difficult, because you're not just talking about taking a piece of data and encrypting it. You're talking about how do you properly create a cryptographic key, how do you properly manage and store this cryptographic key in the secure fashion. So it makes things a whole lot more complicated. Second point, storage must be independent of hosts and containers. And again, I alluded to that using legacy approach to either storage management or storage security is just not going to fly, because we're not just talking about storage tied to servers. We're talking about containers spinning up on various hosts and needing to have access to that storage. So, for example, your payroll system will need to have access to its data regardless of whether it runs on host 1 or host 2. Doesn't yet matter. And third and very important point, and that goes back to one of the slides previously, which alluded to why is it so difficult to deploy security, is that the separation of duties. I really do not want to ask my developers to learn about encryption keys and to know that they have to execute certain commands before spinning up containers. So developers should have no knowledge, no required knowledge of security, and security should be so unintrusive that there's really, no impact to developer workflow, no impact to performance, and the security is really between the security admin and sometimes the IT administrator at the setup time. So just keep that in mind as you're architecting your containerized application.
All right, so let's talk about this now. So now this brings us back to where we started. So now give us the full description of how does this look from the user standpoint. What is it we're actually building here now?
Right. So let's say I'm an enterprise that hosts any kind of data for various healthcare providers. We're looking at healthcare as examples, but it could be anything. Could be telecom, could be software vendors. It doesn't really matter. The point is, there's not enough space on this slide to depict the n number of Docker hosts which will run in a typical enterprise. Like Brian said previously, this could be in hundreds and hundreds, and if not thousands of hosts. Every host, of course, will run virtualization and will run containers. So I have an example of 2 hosts running 3 containers or 2 containers each, but it'll be hundreds of hosts and running hundreds of thousands of containers. Those containers, they will not belong to a single application. They will not even belong to a single customer. It's going to be a heavily multi-tenant environment. Like you see here, even within the scope of one Docker host, you have containers potentially running United Healthcare, Cigna, and Anthem, and on a different host, you run some other application from Anthem and some other application from Cigna. So maybe you are a intelligence provider for a healthcare community that analyzes and aggregates the data from different healthcare providers and provides some intelligence reports to them to provide better services to their customers. You will run all of those applications. If the applications are not properly secured, then compromising, let's say, a one container on one host that belongs to United Health will compromise all of the containers on all of the hosts, because the legacy encryption says encrypt the storage will be encrypted with a single key, or even multiple keys, but a small number of keys, not directly tied to the applications. What we're seeing here is that as you segment the storage to associate it with containers, that segmented storage not only is container specific, the encryption of the storage is also container specific. So to make a complete example, if I'm, as a bad actor, managed to break into a container 2 on host 1 that's running a Cigna analytics software, the Cigna analytics software will be compromised, the data will be exposed, but United Healthcare, Anthem data, and Cigna other call center application will not be compromised. This is achieved by reasonably simple technology that allows you to associate unique volumes with containers and associate unique cryptographic keys with every volume. In a practical real-life example, I want a unique key for my home that I'm in possession of. Even if I live in a community of multiple homes, I don't want to share keys with other members of the community. So that's essentially what this slide is about. Separate the storage, separate the keys.
Okay, so now when you say separate the storage, separate the keys. Now, so what we have here, I just want to clarify this for my own understanding and for anyone else who's watching. So this box right here, so this is 3 separate volumes.
Correct.
Okay, all right. So
and every volume is tied to a specific container. They're not the volume itself is not shared with the container. The volume itself is not shared with other containers.
Okay. So basically you have one disk. So you may have, say, one disk on this host that's been separated into multiple volumes.
Correct.
Got it. Okay. Let's take a look at a little bit more in-depth architectural look at how that all would work.
Right. So we talked about two fundamental things here. One thing is separating the storage per container and separating the keys so that every container volume is encrypted with its own unique key. So this slide gives a pretty in-depth architectural overview of how you would do this and how we actually at ZSET design our encryption solutions. You look at multiple containers running on the same host. They're obviously sharing storage. So what you do is, again, you will start by making sure that every container has access to its own storage and the container is not sharing storage with other containers. If you recall, Brian was mentioning a default configuration of Docker, which is essentially just store the data on a volume, and different containers can store data in different directories. So that's obviously not what we're talking about here, and that's obviously not consistent with, security in mind implementation.
Right.
What we want to do, we want to actually integrate directly into the Docker storage provisioning, which is also known as the volume driver subsystem. And we want to address the container associated with storage and cryptographic keys per storage unit. We want to address it at that level. What we're doing is we're taking a disk or a collection of disks, splitting it up on finite number of partitions, and we're introducing a volume management scheme by which our volume driver is actually capable of provisioning volume of a requested size across one or more partitions that can span one or multiple disks on the same host. So, for example, the Cigna healthcare application, for the database, it may request a terabyte worth of space. We can analyze the space available on the host and allocate a set of partitions on, let's say, SDB or SDC or SDB, SDC, SDD, and so on and so forth, and construct a volume that will be uniquely associated with that container. And the volume will be of a given size. That volume will be then encrypted with a unique key that is securely stored in the key manager. And in the spirit of containerization, the key manager runs in its own container. It's secured by the certificate authority infrastructure. So the communication with the key manager cannot be compromised and cannot be spoofed. And at the end of the day, once this is all deployed, the container has its own volume encrypted with its own key. The beauty of it is that a lot of things that I just described, they happen under the hood. They do not require any intervention from developers. Developers literally run the exact same Docker commands as they were running before. And because we integrated on the Docker storage layer, now there is no need for developers to know what encryption keys are and how to provision volumes and so on and so forth. So it's completely transparent.
Okay. So they don't have to do anything special at all.
Absolutely nothing.
Okay. All right. So so what would you say the key takeaways from all of this then?
So I think the key takeaways, very, very important. Don't let security be an afterthought. Build and containerize with security in mind. And on a personal note, I want to say that now that we're venturing into containers, it's our opportunity for a do-over, because we were designing client-server applications and then we're slapping on security and it wasn't working very well. We were designing a virtualized environment, we were attaching security as an afterthought. It was not working very well. We're now venturing into containers, which says redesign your applications, at least to an extent, to run on containers. So let's hope we get this right this time around, because I think it's the third or fourth go around that we get in the computer science world. So let's get it right and let's get the security baked in and designed in. Security is not the enemy. I really like this one because, yeah, we've been doing security for a long time and it's been really hard to implement in the past. Our goal at ZetaSet is to make security so easy to deploy and so easy to implement that there's really no excuse. You cannot use an excuse that security is hard to deploy as an excuse for not deploying security. We will not give you that opportunity.
And let me just interrupt. Even if you're not using ZetaSet, you still don't have an excuse for not using security.
Yeah, absolutely,
Exactly.
absolutely. We're just trying to make life easier.
Right. Okay. Keep going.
Yep. And so security is not one solution. Your house is protected by a lock with a key. You have security cameras in the house. You have Wi-Fi with firewalls and hopefully properly configured, hopefully with a password that is not anybody's birth date, and so on and so forth. The point here is the security is essential, and security is a combination of technologies, combination of software packages that will get you the proper perimeter and the proper security once somebody breaches the perimeter, because it's not a question of if it's going to happen, it will happen.
And I think this goes right back to the castle analogy.
Yep, absolutely.
Is really what those last two say is it's a layered approach. You can't do one and rely upon that for every piece of protection. You need to do multiple ones. And I think step by step to go to DevSecOps, that philosophy involves all of them. A lot of people have the access control. Maybe somebody doesn't have audit and logging at that point. And one thing we've seen as we've just talked with different what I would call integrity of containers, the different defense mechanisms that are out there, a lot of them are still waiting on the data encryption as the final piece. And you can see it. I think the education is continuing to happen. And once we get that last bullet point, I think you'll really see another level of security. With considering the current environment we live in the globe, there are always going to be bad actors. And I think containers as a whole, because like Maxim said, they've taken a whole new architectural view and they're dispersed more. That means there's more attack vectors out there.
Absolutely.
And we have to be able to, at a minimum, encrypt them as a last line of defense, and we being the world. And I do believe that this is something that shouldn't be after the fact. It should be with the access controls and audit and logging.
All right. Excellent. Anybody want to say anything else before we go to Q&A?
I think we kind of.
I think we covered.
Yep.
All right. So we'll take that as a no. And let's go to Q&A. All right. So if you have not yet entered your questions in the question pane, now would be the time for you to do that. Let's just kind of jump in here. Okay, so we'll just kind of start up here at the top. Maxim, why is encryption so important if we wrap our existing security around all workloads?
Yeah, great question. And it goes back to what we were discussing when we talked about why is containerized environment different than legacy environment. A single word answer would be multi-tenancy, because multi-tenant data centers are usually, depending on the segmentation of the hardware, multi-tenant containerized environments are entirely in the software stack. So we cannot just take a legacy, existing encryption technologies or security technologies and apply it to the entirely software stack of containers and just call it a day. We have to do something that's specific to containers. We have to do something that integrated directly with containers and works seamlessly in the containerized environment.
Okay. Brian, how big of a component of DevSecOps is encryption? If you take advantage of a solution like ZetaSet, what else remains to say we have a, quote, DevSecOps practice, unquote?
Good question. Yeah, kind of like, how do I know if I'm doing it right?
Yes.
So I would phrase that as encryption needs to be as big as needed to satisfy your company's risk management policy. Every company has a different level of risk. Every company has different subsets of controls within a security framework, like PCI, for example. right? Just because you sell stuff over the internet doesn't mean you're handling payment, for example. So your subset of controls for PCI might look different from other players in the same, online, reselling space. So it's as big as needed to satisfy your company's risk management policy. And one other thing to keep in mind is DevSecOps really is like the implementation of it is a combination of both industry best practices as well as the layer of security that pertains to your company's business model, kind of like I was just talking about regarding risk management. So there are very well-defined industry best practices for many components. I'm talking about CIS benchmarks, right? Stuff that you can easily download and run and get a quick assessment as to how you are doing compared to those benchmarks. But then you also have to define the layer that pertains to you. So in order to say I have a DevSecOps practice, we're talking about having a team that focuses on understanding the attack vectors and then identifying the controls that are relevant to your workload and your business, and then having the means to implement those controls from a technology perspective, whether that's encryption, like we're talking about here, or RBAC, or network policies, or some of the other things that we discussed earlier.
Or all of them.
Or all of them, exactly.
Okay. And is it fair to say that you're better off with too much security than not enough security? I mean, is it fair to say it's better to err on the side of being too careful?
Yeah, again, like I mentioned earlier, you want to stay off the front page of the headlines. I'm sure Marriott, in light of the current environment we're in, did not need to exacerbate their problem with a security breach. So definitely err on the side of caution.
By the way, I don't think there's such a thing as too much security. I think there's security that you choose not to implement, but I don't think there's too much security.
Okay, well, there you go. So yeah, that's probably true. All right. Okay, Maxim and Brian, what is the most common security incident reported for containers?
Yeah, I'd say, like Tim and Maxim have been talking about, the breaching of data breaches, right? Kind of storming the castle. Storming the castle is made possible by not locking down your environment in terms of network access policies, the RBAC, lack of implementation of least privilege, right? Think of a top secret security clearance in the government, right? A need to know basis. Explicitly defining that will avoid a lot of problems. But yeah, I'd say most common security incident is access to data by somebody who shouldn't be there.
So let's go here. Can you clarify the ephemeral nature of the key manager container and how it securely accesses the keys and how those are stored securely? Can the system leverage key storage like KMS in AWS?
That is actually a wonderful question because it speaks to several important things. One is, so yes, key manager in the containerized environment should run in container. There's been a lot of work done on key managers over the past, I want to say, 20 years. We started with proprietary key managers. We moved into key managers supporting what's known as the KMIP, Key Management Interoperability Protocol, which is essentially a common language that every key manager out there talks. So the key manager we run in container as part of our solution is fully KMIP compatible, integration tested with other encryption solutions and of course ours. Understanding that enterprise security requirements may be different, we are providing you with a software-based key manager, but we're also understanding that you may already have investments in existing, SafeNet, Gemalto, Talos security key management infrastructure. So we're allowing you to connect very simply and very easily to any existing key management infrastructure that you may have. We're doing the key management, I want to say, the right way, meaning we have a KMIP compatible key manager that stores the key in a key data keys in a key database, Key database, of course, is secured with a hierarchy of master keys and hashed with appropriate hash keys. Those keys are stored in the software security module, which is essentially a software implementation of your typical HSM. We're also, and any solution, as it should be, PKSS 11 compliant, which means we can talk to hardware HSMs if required. Hardware HSMs are essentially hardware devices that store master keys securely. The reason I'm saying all this and giving such a detailed and somewhat technical answer is that when you look at an encryption solution, you should make sure that it does the good job, housekeeping. Because if encryption is an afterthought, that, believe me when I tell you, key management is not even on the map of thoughts that in mind, but it should be.
Okay, it should be. Hear that, everybody? Key management. Make sure you think about it. Okay, so how does the driver know what size storage to create if the developer isn't doing anything different in Docker? It seems that the developer would have to specify that size. I'm not clear on exactly what they're asking here, but I'm sure it makes sense to you.
Oh, I understand the question perfectly. Yeah, it's a great question because we talk about transparency, and now we're saying, well, when you specify a volume, we need to know what side of the volume you allocate. So it's kind of an additional burden of the development to ask for a certain amount of storage. There are two options that at least our solution is providing. And one option is storage volumes can be pre-allocated by administrators, and that's very well integrated with the Docker create volume command. So administrator can specify a volume for, let's say, MySQL database and specifies the size there. The second option is an administrator at the time of installation of our software can specify the default size of the volume that the container will get. And then a developer simply runs Docker run command and doesn't have to specify the size of the volume, and the volume gets allocated.
Okay.
And the third option, nothing gets specified, and we just specify a default. We resolve the default value of the volume size that's specified during the installation of the software. So between the three, transparency should be addressed.
Okay, we have 3 minutes left, so we'll see how many more we can get to. How do you handle encryption when containers move from one host to another host?
So when containers move between hosts, the data doesn't necessarily move between the hosts, because one of the, I think, second point out of the three important bullet points is that the storage should not be hardwired or should not be associated with the host. In a typical distributed environment, when you have processes running on different hosts, this is addressed by having shared storage, but shared storage is still managed by Docker daemons that run on hosts. And so we're able to handle the storage allocation to the container on the shared volumes, just like as we're able to handle storage allocation to the containers on the volumes which are hardwired to the host. So the point is, we can use storage that is tied to the host, or we can use the storage that is shared between the Docker hosts.
Okay. Last question. You have 45 seconds. What is the performance impact of encrypting data in containers?
Great question. With our solution, we're running in containers, but we're running within the kernel. Performance impact is low single-digit percentage. You're looking at between 2 and 7, but definitely lower than 10% performance degradation. And performance, I'm going to use another 5 seconds to say performance is critical, because you don't want your encryption solution to slow down your analytics system, bring it down to its need. It happened before. That's why people are rightfully concerned. Performance, minimizing performance overhead is one of the fundamentals of our solution.
All right, excellent. Well, we are at the end now. So what I'd like to do is I would like to remind everybody that there are some downloads that you can get. There are 3 handouts in the interface, and I would like to thank our featured presenters today, Maxim Yankovsky and Tim Riley, and our own Brian Langston. And as always, I want to thank our super producer, Michelle Yokura, without whom all of this would be completely impossible. And the most important component, all of you out there who took your time to be here with us and hopefully get a few minutes of quiet away from your kids. And hopefully everyone is staying well and staying safe, and stay home. And we'll see you next time, and everybody stay well. Bye-bye.
All right. Thank you.
Bye.
Thanks. Bye-bye.